Okay, so what we've got is we are going to be talking about in this question, or in this topic, I should say, the tangents or some geometry using polynomial techniques. And we're going to be focusing on midpoints and tangents. So when two curves intersect, we can form an equation whose solutions are the x or y coordinates of points of intersection of the two curves. So the midpoint of the points of intersection can then be found using the average of the roots, and tangents can be found or identified as corresponding to double roots. Okay. So what we're going to be looking at is a question, and it could be easily done using quadratic equations, but it is a very clear example of the use of the sum and product of roots of these style of questions. Okay. So it says here the line y is equal to 2x meets the parabola y is equal to x squared minus 2x minus 8 at the 2 points alpha 2 alpha and beta 2 beta. Now what we want to do is we're going to show that alpha and beta are roots of that equation, okay, and hence find the coordinates of the midpoint of M of A and B. So as I just said, the midpoint is the average of the intersection of the two curves. So we're going to be starting off by looking for the intersection of, that was weird, the intersection of the two curves, okay? So that is, we've got equation y is equal to x squared minus 2x minus 8. We've got y is equal to 2x. So what I can do is I can make these two equations equal to each other. So 2x is equal to x squared minus 2x minus 8. Okay, and then by solving or moving the 2x to the right hand side, we get 0 is equal to x squared minus 4x minus 8. Now, what we want to do is we want to actually calculate what our roots are. Now, there's two quick ways that we can do it. Hopefully you remember from just before. And one way is to do the sum of the roots, and the other way is to do the product of the roots. Now, as we said, to identify the midpoint of the points of intersection, okay, all we need to do is we need to take the average of the roots, because the midpoint of a parabola is just the halfway point of the zeros, okay? And that way we can literally find this missing point, or this missing point. So what we can do now is we can actually find what the sum and the product of the roots are. So remember, the sum of the roots are equal to minus b over a, and the product of the roots are equal to c over a. Okay, so by identifying the sum of the roots is minus b over a, well, that gives us 4, because minus 4 over 1 is 4, and the sum is minus 8 over 1, so it's just minus 8. So that's the product, I should say, not the sum. Now, what we can do is we can take the average of the two roots, because remembering the average is that halfway point of the two roots, and that'll give us the x value for our midpoint. Okay. So remembering that the average of the two roots is just alpha plus beta on 2. Okay, so this is the average, and what we can do is we can just put in our value that we found for the sum, which is 4, and put that over 2. So then x must be equal to 2 is the x value. So that's the x value for the midpoint. Okay. Now, to find what our y value is of a and b, we can substitute that into either one of the two equations. I'm going to do the y is equal to 2x, because that is the value that's going to give us a nice midpoint. Okay, so y is equal to 2x at x is equal to 2. So therefore, y is equal to 4. And 2, 4 is the midpoint of A, which is alpha 2 alpha, and B, which is beta 2 beta. Now what I'm going to do is I'm going to quickly show you on this sketch here. So basically what we said is, okay, we don't know what that exact point of intersection is, and if you can have a look, it's kind of a weird number, like it's not a number we're used to. There's another one there as well. What we're saying is that we can find the halfway point between these two by taking the average of the roots of the difference. So if I take the minus 4x, okay, oh no, the minus 2x, sorry, okay, and so the sum or the difference of the roots is going to give us that halfway point. So the halfway point between this one here and this one here, we decided was at 2, which is here. So this point here at 2, 4 should be the halfway, or is, I should say, the halfway point between here and here. Now, part B of this question says, use the identity alpha minus beta squared is equal to alpha plus beta squared minus 4 alpha b. And there should be a second half of the question, and the second half, which I didn't add in for some reason, is to find the horizontal distance alpha minus beta from A to B. Okay, so what we're going to do then is, first off, I'm going to actually show you that identity. So the identity says that alpha minus beta squared is equal to alpha plus beta squared minus 4 alpha beta, okay? So let's have a look and actually expand that and see what that identity actually means. So this is more of like an aside. So alpha plus beta, no, sorry, alpha minus beta squared is equal to alpha plus beta squared minus 4 alpha beta. Okay, so expanding the left-hand side, we're going to get alpha squared minus 2 alpha beta plus beta squared, and that's equal to alpha squared plus 2 alpha beta plus beta squared minus 4 alpha beta, okay? So as you can see, alpha squared minus 2 alpha beta plus beta squared is equal to, now we've got minus 4 and we've got plus 2 of the alpha betas, so that's going to give us alpha squared plus beta squared minus 2 alpha beta, which is, if you rearrange it, the same thing. So basically this identity, okay, is something that they've given to you, and in most situations you don't need to actually show that they're the same. I was just showing you that these two sides were the same though, but what we're going to do is we're actually going to use this identity to identify that. And the reason why we've got this one is because we don't know anything about the difference of the roots, but we do know something about the sum and about the product. Now, remembering that the way that we get the distance, so distance squared of a on a Cartesian plane is just Pythagoras. It's just the it's just the I think, is it the difference? Because I believe it's Pythagoras, so it's x squared. So if you were to do the Cartesian coordinates for this, it'd be x squared minus, x2 minus x1 all squared plus y2 minus y1 all squared. Now, what we've got above here is we have the difference in the two values, in the two roots. Now, think of the two roots along a straight line. So here's alpha here, here's beta here. We're trying to work out what's the difference between the two, okay? Or how long is it between the two roots? So the horizontal distance, so there's actually no y values at all. So we're only concerned about the x values, and our x values are our beta and our alpha. So in fact, our d is equal to alpha, or d squared is equal to alpha minus beta squared, which means that, there should be no square root there, by the way, which means that d is equal to the square root of alpha minus beta, all squared like that. So I'm just explaining why this identity has come to be. So using this identity, okay, So we know that alpha minus beta squared is equal to alpha plus beta squared minus 4 alpha beta. We know that the sum of these two is equal to 4. So this, or alpha minus beta all squared, is equal to 4 squared minus 4 times alpha times beta, which is minus 8. Okay, so 4 squared times 4, minus 4 times 8. So that's 16 plus 32, which means that this is equal to, or alpha minus beta all squared is equal to 16 plus 32, which is equal to 48. Now, normally what would happen is we would take the square root of both sides, and that would give us a positive and a negative answers. But because we're trying to find the distance, to find the horizontal distance, okay, we only are concerned about the positive value. So that's why we had that absolute value. So alpha minus beta is equal to the positive square root of 48. Okay, and by simplifying that surd, we get alpha minus beta is equal to the positive 4 square root of 3. Okay. Now what we're going to do for the second part of the question, which I have not got written down, it's written underneath it, is it says then use Pythagoras' theorem and the gradient of the line to find the length of AB. Okay, so because the line is y is equal to 2x. Okay, so we're looking essentially, there's this line on here, okay, it's like here something, and there's the intersection point like that. Okay, we're trying to look for the distance between here and here. So what we did is we found the distance between these two by using this guy over here. Okay, now we're looking for the distance along here. So to do that, we're going to need the distance along here. Okay, so because the line has gradient 2, okay, that is that this gradient along here is equal to 2. The vertical distance is 8 over root 3. Now the reason we know that is because if you think back to your rise over run, okay, if this line here has gradient 2, so we already know what the gradient is, and we know that the run is 4 root 3 on x is equal to 2, like this, this should be y, okay, we can work out what that distance in the y is by multiplying both sides by 4 root 3. So y is equal to 2 times 4 root 3, which means that y is equal to 8 root 3, okay? So now that we've got the y value, that vertical, so that's that vertical distance there. So this is 8 root 3, which is double of the length, which is 4 root 3. We can actually use Pythagoras now. So the distance of a to b squared is equal to the square root of, oh sorry, not the square root, not quite yet, is equal to 8 root 3 squared plus, and our other number is 4 root 3 squared. So 4 root 3 squared, okay? So 8 root 3, so 8 root 3 times 8 root 3 is 64 times, sorry, let me rephrase that. Okay, so 8 root 3 times 8 root 3. What we're going to do is we're going to multiply the numbers first. So we're going to get 64 times 3, which is equal to, this doesn't feel right. But anyway, we're going to keep going. Okay, 64 root 3, which is equal to 64 times 3. So I'm going to use a calculator for that because I can't think. 192. Okay, so this is so AB squared is equal to 192 plus 4 root 3 times 4 root 3. So 4 times root 3 times 4 times root 3 is equal to 16 times 3, which is equal to 16. 16 times 3, which is equal to 48. Okay, and so we get 192 plus 48. So that's what AB squared is equal to. So AB is equal to the square root of the sum of that. So we add that on to 192. That's going to give us 240. And the square root of 240, I don't think it's a nice number, so we're going to have to take a thing for this. Or in other words, use our calculator that has a surd setting, I guess. But it's 4 root 15. And that is the distance of A to B. So A to B, these two magical roots are equal to that. Now, our last part of the question, part C, is find the value of B, for which y is equal to 2x plus b is a tangent to the parabola, and find the point T of contact. So we want to find the value of B that makes the tangent to the parabola, okay? And we want to find the point T of contact. So scroll down to a new bit. I'm going to go C. Okay. So what we're going to do is we're going to solve simultaneously to find a value of B to begin with. So we go y is equal to x squared minus 2x minus 8. And we've got the equation y is equal to 2x plus b. And we're going to solve simultaneously. Okay, so that is x squared minus 2x minus 8 is equal to 2x plus b. Okay, so basically it's the same as that line before, but it's just going to be shifting up and down. Okay, and we want to work out how far down do we have to shift it to make it so that it is the tangent. So if we have a look, basically what we're saying is if we've got this, how far do we need to move it down so that it gets to the, so that this becomes the tangent. So that's essentially what we're asking. So, solve simultaneously, move it to the left-hand side. We're going to get x squared minus 4x minus 8 minus b is equal to 0, just like that. Okay, and what I'm going to do is I'm going to take factor of the negative out, and I'm going to be left with 8 plus b is equal to 0, like that. Okay, now because the line is a tangent, let the roots be the same, like, because what we're essentially doing is we're going to use that other idea that the tangents are a double root. So we're going to make the roots the same. So therefore, x squared minus 4x minus 8 plus b equals 0 has zeros, alpha and alpha. So they're basically the same 0. So what we can do now is we can use our sum and our product, the sum of the root zeros and the product of the zeros, to give us alpha plus alpha, which is equal to, and as we know before, the sum of the roots from this initial equation was equal to 4. And that must mean that alpha must be equal to 2, because this is the same as 2 alpha is equal to 4. Okay, and now we can use the product of the roots. So that is using that this part here. So our alpha is equal to, now it's the c over a, so it's minus 8 plus b. Now we already know that alpha is equal to 2 from using the sum, the product, sorry, the sum of the zeros. So alpha squared is equal to minus 8 plus b. So alpha squared plus 8 is equal to b. Now alpha is equal to 2. So 4 plus 8 is equal to b. So 12 is equal to b. And that should give us our value for b, which makes this equation true. So to make the tangent, okay, so we've got y is equal to 2x plus b was the tangent, and we now know our tangent's b value is equal to 12. So what should happen is I should, and it was minus not plus, okay, because if we go back up to here, if we go back up to this should be in brackets here. I just realized, so that should be minus, so that should be minus, so that should be minus there. Now, so if we go back down to our picture here, if I change that b to minus 12, you'll notice that it does make that contact here. Now our last bit is to show that that point of contact is 2 minus 8. So to show that the point of contact is 2 minus 8, all we're going to do is just substitute some values into it. Now, what we need to do is we need to find, well, when are those two equations equal? So we know that they're equal up here. Okay, so all you have to do is substitute the value of b back in, and then you can rearrange for the x to get the x value. And if you do so, you get x is equal to 2. Actually, we might just do that one. So x squared minus 2x minus 8. Well, we can put it into this one here. This one's a bit easier. So x squared minus 4x minus 12, I believe. Just trying to think. Yeah. So we'll go. Keep forgetting what I'm doing. Okay, so we're gonna go, where is it? So we'll do it on this one here. So x squared minus 4x. So x squared minus 4x minus 8 plus x, I think it was it 8 plus x? 8 plus b, so it's minus 12 now. So that would be minus 4 is equal to 0. So x squared minus 4x plus 4 is equal to 0. So this one is going to give us, so two numbers that add to give 2 and multiply to give 4 and add to give negative 4 is going to be x is equal to minus 2, and that's going to be squared, which is equal to 0. So x must be equal to 2. So that's how we get our x is equal to 2. And then for the y value, substitute it back into the tangent. So y is equal to 12, not that. Y is equal to 2x minus 12. So y is equal to 2. So I should say x is equal to 2. Y is equal to 2, lots of 2 minus 12. So y is equal to 8 minus 8. And that is our point. So the point of contact T at 2 minus 8. Now there is another example, but I'm not going to go through it because that one took long enough. I'm going to leave it there, and that's going to finish off our polynomials topic. This last topic is quite tricky, and the last few are pretty tricky, but I think you guys will be right with it. So if there are any issues, please let Sean, you make me know in class time, and I will help you guys out as much as I can. So with that being that's the end of these videos, and that's the end of the polynomials topic, and I'll talk to you guys in a bit.